Alright, let's dive right in. Today, we are going to tackle one of the topics that trips a lot of people up on their math exams, graphing functions. But trust me, by the end of this, you'll be able to look at an equation and just see the graph in your mind. You know that feeling, right? You see a question asking you to sketch a graph, and your mind just goes blank. Well, if that's you, you're in exactly the right place. We are going to clear all that confusion up, step by step. No more guesswork. So, where do we start? We start with the absolute foundation, the OG of graphs, the linear function. And there's a reason they call it linear, it makes a perfect straight line. Let's use a really simple example, y equals 2x plus 3. Now, don't just see this as a bunch of numbers and letters. Think of this equation as a recipe, or a set of instructions. Every single part of it is telling us exactly what to do to draw our line. And here's what happens when you follow those instructions. A perfect straight line. See those 2 points we've marked out. That red one at 0 and 3 is where our line hits the vertical axis. The green one is just another point along the way. But these aren't random. Their exact location is dictated by our equation. That red point has a really important name. It's the y-intercept. It's literally where the line intercepts the y-axis. And honestly, it's the most important landmark you've got. Think of it as your starting point, your home base. And here's the cool part. In our equation, y equals 2x plus 3, that plus 3 is literally telling you to start at 3 on the y-axis. So let's lock this in. If you see an equation like this, here are your clues. First, the shape. It's always going to be a straight line. Easy. Second, that number hanging out on its own, the plus 3, that's your y-intercept, your starting point. And third, that number next to the x, the 2, tells you the slope. Since it's a positive number, our line is going to travel upwards as we go from left to right. Simple as that. Okay, we've got straight lines down. Let's level up. We are about to see what happens when we add just one little twist to the equation. We are leaving the world of straight lines and entering the world of curves. Let's look at y equals x squared minus 4x plus 3. So what's the big difference you spot right away? It's the x squared term, isn't it? That little 2 up there is the game changer. That is the single thing that takes our nice, predictable straight line and bends it into a totally new shape we call a parabola. And boom, here's what that x squared does. It creates a beautiful U-shaped curve. Now, this graph has a whole bunch of new, important features. We still have a y-intercept. You can see it there in blue. But look, we also have these 2 green points where the graph crosses the horizontal x-axis. And maybe most important of all, we have this critical red point at the very bottom of the U. That red point is called the vertex. On this graph, it's the absolute lowest point. It's the turning point where the curve stops going down and starts heading back up. I'm telling you, for any parabola, finding this vertex is your main mission. It's the key to the entire shape. Okay, what about those green points? These are called the roots, or you might hear them called the x-intercepts. They are super important for exam questions because they are basically the solutions to the equation. They show you exactly where the curve comes down and hits that horizontal x-axis. And one last thing. See that dotted line running right down the middle, straight through the vertex. That's the axis of symmetry. It's an imaginary line, but it's incredibly useful because it perfectly splits the parabola into 2 identical mirror image halves. If you know one side, you automatically know the other. So let's recap the vital stats for this particular parabola. Its shape is a U-curve. Its vertex, that crucial turning point, is at the coordinates 2, -1. It crosses the y-axis way up at 0 and 3. And its roots are at 1, 0 and 3, 0. The whole thing is perfectly symmetrical around that vertical line x equals 2. Alright, theory is great, but let's get our hands dirty. This is where the rubber meets the road. We are going to pull up some real past questions from WAEC and NECO exams and see how everything we just learned makes these problems way easier than they look. First up, a question from WAEC 2018. The equation is y equals 3x minus 6. Okay, pause for a second. Just look at that equation. Do you see an x squared anywhere? No. So what kind of graph are we expecting to see? Exactly. It's gotta be a straight line. Now, to solve it, we just need the key points. That's minus 6 at the end. That immediately tells you the y-intercept is down at 0, -6. And to find the x-intercept, you just quickly set y to 0 and solve for x, which gives you the root at 2, 0. That's it. You have everything you need to sketch the line. Let's try another. WAEC 2020, the equation is y equals x squared plus 2x minus 3. And right away, that x squared should be like a giant flashing neon sign for you. We know we are not dealing with a straight line anymore. We are in parabola territory. And solving it just means finding those key features we learned. After you do the calculations, you find out the vertex, that turning point. Is it -1, -4? The roots, where it hits the x-axis, are at -3, 0 and 1, 0. And you know its line of symmetry runs right through the vertex, at x equals -1. You can now perfectly picture this U-shaped curve in your head. Okay, one final example. This one's from NECO 2020. The equation is y equals -x squared plus 4x minus 3. Now this one has a tiny but super important twist. Look really closely at that first term. It's not just x squared, it's -x squared. What do you think that little minus sign is going to do? It flips the whole thing upside down. That's all it does. That negative sign in front means instead of a U-shape that opens up, we get an N-shape that opens down. And that changes one big thing. The vertex, which is at 2 and 1, is now the highest point on the graph, not the lowest. The roots are still where it crosses the x-axis, which are at 1, 0 and 3, 0. Wow, we've covered a lot of ground. So let's boil it all down into one final, super simple checklist. This is the mental cheat sheet you want to take with you into your exam. Here's the bottom line. On exam day, if you look at an equation and you do not see an x squared, you know it's a straight line. Your first job is to find that y-intercept. On the other hand, if you do see an x squared, you know it's a curve. Your mission is to find its turning point, the vertex, and its roots. That's it. That's the core strategy. So now you have the toolkit. You can see the patterns. You can spot the clues just by looking at the equation. The only thing left to do is to try it yourself. So go on, what graph are you going to tackle next?